Hi folks, now we're in section 7.4, parallel and proportional parts. And we're going to be learning some theories. Some theorems. The first one is triangle proportionality theorem. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. And essentially what it's saying is that if you have these two parallel lines, then you can set up a proportion saying that the relationship between AB and BC should be equal to the relationship between AE and ED, because the parallel lines are creating these equal sections. So let's go ahead and try it. In example 1, we have our triangle, and we know that ST is parallel to RQ, and we have our marks. Now, if PT is 7.5, so we have 7.5 here, and TQ is 3, SR is 2.5, and we're trying to solve for P to S. So we can go ahead and set up a proportion. 7.5 over 3 is equal to X over 2.5. So you go ahead, and when we have the proportions, we can do the lasso. And we get 3X is equal to 18.75. Divide by our 3, divide by our 3, and we'll get X is equal to 6.25. So in this situation, we know X is going to equal 6.25 based on the triangle proportionality theorem. So you can pause the video now and try this one, or you can listen and take notes. I suggest you try it though. So the first thing I'm going to do is I notice my lines are parallel, therefore I can use the triangle proportionality theorem. And if P to S is 12.5, I always notate my work, S to R is 5, P to T is 15, and we don't know T to Q. We're trying to find that, solving for it. So I'm going to go ahead and set up my proportion. I will do 12.5 is to 5 as 15 is to X. Go ahead and do your lassos, and you'll end up getting 75, because 5 times 15 is 75, is equal to 12.5 X. And then just solving the equation. X equals 6. So in this situation, TQ equals 6. And I didn't name what was the final result on the first slide. I should have. I kind of ran out of room. So let's go on to the next theorem. We're looking at the converse of triangle proportionality theorem. Now, as soon as you see converse, you should be thinking that we're going to be switching our if-then. And we are, in fact. Here we're saying if the proportionality is true, then the lines are parallel. So we're looking to prove that those sides are proportional. So looking at this example, we have EH is 3 and HF is 9. Now, for the next side, they're saying that 1/3 of the length of they're saying that DG is 1/3 of the length of GF. So if DG was X, it's 1/3 of GF. Well, wouldn't that be 3 times the value of X? So rather than deal with fractions, I just label what they're giving me as X, and then I multiply the other segment by 3 to get it to be 3 times the length of DG. So let's look at what the fractions would simplify down to. We have 1 over 3, because 3 is to 9, which reduces to 1/3. And if I look at this side, I have X over 3X. My X's are going to cancel, but I still have a 1 up here. So in theory, I still have my 1/3. Actually, not in theory, in actuality. So the relationship is 1 to 3 on the right side and 1 to 3 on the left side. Therefore, I can say that DE is parallel to GH. Now moving on to example 2. Again, you can give it a try before you listen to this portion. In this situation, we have DG is half the length of GH. So if DG was X, I've got all sorts of bells, I'm sorry. If DG is X and GF would be twice that because DG is half the length of GF, so GF is 2X. So EH is 6 and HF is 10. I'm just taking the information from the example. So on the right side, 6 over 10 would reduce down to 3/5. And on the left side, I have x over 2x. These would cancel, and I would end up with 1/2. So if I have 1/2 for the left and 3/5 for the right, those are not the same. Therefore, DE is not parallel to GH. Okay, the proportions would have to be identical, or we would have to have identical measures on each side, and they're not. So they're not parallel. And our final theorem is the triangle midsegment theorem. Midsegment of a triangle, oops, I didn't mean to cross that out, but a midsegment of a triangle is a segment with endpoints that are the midpoints of two sides of the triangle. Every triangle has 3 midsegments. So basically what it's saying is, we have a midsegment connecting two sides of the triangle, and it creates congruent segments for the sides of the triangle. There are 1, 2, and I'm going to do it in pink again, 3 different midsegments. So basically we can create a smaller triangle within the bigger triangle. And the really cool thing about this is that a midsegment of a triangle is parallel to one side of the triangle, and its length is half of the length of that side. So what that means is, from J to K, this measure here is half of F to G. So any midsegment you have, you can find the length of the side of the triangle by doubling the midsegment length. So let's apply this. So your paper will not have the ABC written on the left, but this is what we're looking for this problem. So in the figure, XY, we have our XY and XZ are midsegments. So we know they're parallel to the sides across from them, and they're also half of the length, or half the measure. Using this information, we're going to be able to solve for the 3 things that they're asking for. So for the first one, they want XZ, X to Z. Well, I'll look across and see that that length, R to T, is 13. So half of 13 equals 6.5. Therefore, XZ is 13.5, excuse me, X to Z is 6.5. So that's our answer. Now they want us to find S to T. They want us to find this side here. In order to find this side, I need to look at the midsegment, and I see that it's 7. So if the midsegment is 7, we know the length across from it is twice that. It'll make S to T 14. And finally, we are looking for RYX. So RYX. Let me just erase some of this stuff right here. There we go. So remembering that these are midsegments. Midsegments are parallel. Because they're parallel, I know that this angle of 124 here is related to RYX. They are alternate interior angles, and therefore the measure of RYX is 124 degrees. I want you to go ahead and give this one a try on your own, and we will discuss it in class. I hope you have a fantastic weekend. Thank you.